So today we're going to talk about how we represent data in chemistry. Okay, so we're looking at things like chemicals and compounds, and we can quantify those in three different ways. Okay, one is by counting the number of elements or objects there are in the compound. So, how many oxygens, how many hydrogens, that kind of thing. Um, and when we're counting, we're only using whole numbers, right? There's no such thing as a half of an atom. Okay. Um, Mass is the second thing, which is the number of grams of the substance, right? So, counting, we're counting 1, 2, 3, 4. With mass, we're using a mass balance to get that number. And the last one is volume. We use the cubic meter or the milliliter of a substance. Okay, so for mass, again, we're going to use a mass balance, right? It's not like a weight, but for right now, if you use the word weight, you're okay. In most cases, we're going to be using a digital balance to measure your mass. So that means that all you do is record the number as it appears on the digital screen. So if the number comes up as 2.00, you would write 2.00 and then whatever the term is after it. So it'd either be grams or kilograms. Okay. For volume, there's two ways. The first way is measuring liquids, right? The volume of a liquid. And so when measuring the volume of a liquid, we use milliliters, ml, little m, big L. And in most cases, we will be using a graduated cylinder to do that. Remember, graduated cylinders look like this. You've used them before. Okay. To use this tool, we measure the substance at its lowest point. Okay, recording only the digits that you can see. So if I'm looking at this graduated cylinder and I zoom in, okay, I can see that, excuse me, that the lowest point, notice how there's like this little dip right here. The lowest point at that dip is above the 20 mark, right? That's this mark right here. And it's also above the next line, which would be your +1. So that'd be 20 plus 1 is 21. So we know it's above 21 milliliters. Then we estimate, where do you think it falls in between the next line and that line? Okay. So I'm going to say, well, I think maybe it's about halfway, right? So I'm going to estimate that it's at 0.5. So now my measurement then is 21.5 milliliters. You can't go any farther than the 5, okay? Because there's nothing on here that tells us that it would be anything lower than or anything farther than that 5, okay? Okay. Scales and graduated cylinders tell us numbers that we can write down. Great, no problem, right? We call those significant figures, right? So significant figures are the numbers that instruments like the scale and the graduated cylinder, that's what they tell us to write down. But what happens when we have to do math to figure out what the number is, right? Because then sometimes we get these really long numbers. Like let's say I take 17 grams and I divide it by 3. Okay. So now if I do that in my calculator, I get this big long number, and I'm sorry, but I ain't gonna write all that. Okay. What you should do is round or shorten the number. Okay. And you want it to shorten the number to take the same number of figures as the smallest one that you started with, right? So I started with this 17 grams. That has 2 numbers in it, right? So my answer is only going to have two numbers in it, the 5 and the 6. So I would write my answer as 5.6 grams. I don't write the whole thing. Okay. And if you're really savvy about rounding, you could write 5.7 grams. Okay. All right. Your answer should have the same number, or sorry, when there is more than one number involved in the math, like 5.543 and 2.2 seconds, right? If I'm going to divide these to get the speed, right? I divide them. This is what my calculator gives me. Okay. Again, we're going to look at the smallest number that we're given, right? So this one gives me 4 numbers. This one gives me 2 numbers. So my answer is going to be the first 2 numbers. Okay. The only time that it's not the first 2 numbers is when it starts with a 0. Okay. If it starts with a 0, go all the way till you get to an actual number, then start counting. Okay. Good. All right. Now, we can directly measure most things that we need to use, but a lot of times in science, we need to work with what's called derived measurements, which are measurements that are mathematically formulated, right? So, for example, the volume of a metal bar, right? If I have a bar that's made out of metal, right? And I want to find the volume of that bar, I can measure the length and the width and the height, but I have to multiply them together to get the volume. Okay. So let's say that my bar has a height of 0.15 meters. It has a length of 1.55 meters, and it has a width of 0.55 meters. What is the volume of the metal? Okay. So the volume is equal to the height times the length times the width. So all I'm going to do is take these 3 numbers and I'm going to multiply them together. In my calculator, it's going to give me this answer, 0.127875. That's a lot of numbers, right? But remember, we take the smallest number, right? The smallest number of numbers. So I have this one. Remember, we don't count the zeros in the front. So we have 1, 2, right? So there's 2 numbers here. And then this one has 1, 2, 3 numbers in it. And then this one has 1, 2, 3 numbers in it. Okay. So remember, we want to use the smallest number of numbers. So this one has 2 numbers in it. So we're going to shorten this to 2 numbers. So after rounding, my answer would be 0.13 meters cubed, right? Because if I take meters times meters times meters, I get meters cubed. Okay. Okay. So in this lesson, we talked about chemistry using values like counting, mass, and volume. We talked about how mass is measured in grams and is measured with a mass balance. And for digital, we write down all the numbers. Okay. Volume of a liquid is in milliliters and is measured with a graduated cylinder. Okay. Answers are recorded to the smallest number of significant figures. Remember, that's the number of digits that are in the number shown in the question. And then sometimes values have to be derived or calculated.